Hi everyone, I'm back again. I'm here to solve LeetCode problem number 424, longest repeating character replacement. Let's read the problem. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. What's going on right here? So we're given a string s that's AB, and k equals 2. So this means that we can make two replacements. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times, right? So we know that k equals 2, so we can change two characters to another uppercase English character, and we want to make changes such that the longest substring has repeating characters. So in this case, you change B to A, and then you get A, which equals 4, or you change A to B, and you get B, which is also 4, right? So that's the answer. And in this situation, you have k equals 1. So let's take a look. You can for the B's, right? You could change this A right here to a B, and the substring will be B, which gives you 4, right? Let me see. Replace the 1A in the middle with B and form, right? The substring has the longest repeating, which is 4, right? But at the same time, you can also change this B to A, and you will get A, right? Right, you either change this character from a B to an A, or this character from an A to a B, and you get A, or B. If you change this to a B, you get B, which is only 3. So the answer is 4, okay? This is a very challenging problem, and, I had problems with it. I had a lot of problems with this question, actually. So I'm going to demonstrate the solution from Nick White of YouTube, who's very good at this, so all the credit goes to him. And I'm also going to just try my best to do this problem. This is a sliding window problem. Whenever you talk about like substrings, finding substrings, it's almost always some form of sliding window problem. Let's set up the problem. Look at the constraints. 1 is less than or equal to s dot length, which is less than or equal to 10 to the 5th. So you know that the string s can get very large. It can get as large as 10 to the 5th, which is a very, very large number. S consists of only uppercase English letters. This is actually an important constraint in the sense that we know that the character set of the string s it only goes from capital A to capital Z, which we know is a 26 character set, 26 cardinality character set, right? We also know that the value of k is going to be either 0, or it can be as big as the length of the string s, okay? So topic, this is a sliding window problem. And let's take a look at what they say. Okay. This is a hash table string or sliding window problem. We're also this is primarily a sliding window problem, but we're going to incorporate a hash table for sure as we're trying to solve the problem. Let's design the algorithm. And Okay, give me 1 second. My computer needs to be plugged in, so I'll be right back. Okay, I'm back. So let's start designing the algorithm. Define left and right pointers and set them at 0. Define a counts dictionary that will count the frequencies of each character encountered. No, this is fine. Define a variable that will keep track of the current size. Define a variable that will keep track of the current. Define a variable that will keep track of the current. Keep track of the consecutive counts of the same character. Define an answer variable and return it. Loop using a for loop from actually the for loop is gonna loop from right equals 0 to the end of the string s. Update the count of the characters encountered in the dictionary. Update the character. So this gets a little tricky. Update the variable that keeps track of the count of the consecutive count of the same character. See if we should not the word delete, but see if we should update. See if if we can perform an operation to change one of the characters. If so, update the count of the left pointer and by subtracting 1 in the dictionary. Increase the left pointer, and then you have to update the answer and see if we have a new answer. And then you have to increase the right pointer. Yeah, this problem is a lot of stuff. I mean, I don't know how else to say it, but this is a lot of stuff. So let's get the skeleton right. N equals len s. We actually don't need to define L. I'm only going to define the left pointer of the sliding window. The right one I'm going to do in the for loop. We're going to have a another variable called longest equals 0. Longest I'm not going to call it longest. I'm going to call it repeating. Repeating. And then we have an answer. We're going to return the answer, right? For R in range 0 to n, we're going to do the updating. Right, we didn't even define the dictionary. Counts equals, there we go. So then C equals SR. Counts, we're going to do ord of C minus ord of A plus equal 1. So whenever we, as a sliding window, as the right pointer moves to the right, we're going to just keep adding the count to the dictionary, and then what we're going to do is see if we need to update the repeating, right? Repeating equals max repeating, and see if this is the correct one. Not the correct one, but if the new character that we add, if that character that we're repeating on, if it has increased or not. While, and this is where it gets a little crazy, R minus L minus repeating plus 1 is greater than K, then what do? We now we're dealing with the left pointer, right? So C1 equals S of L. It's the same code. Counts ord C1 minus ord A minus equal 1, because we're moving the pointer now. L plus equal 1. And then what we do is we need to deal with the answer, right? Increase the right pointer, obviously, R plus equal 1. And then we need to check if the answer has increased. Answer equals max. Answer L minus R plus 1. I sure hope this is it. N equals len s, L equals 0, repeating equals 0, answer equals 0, counts equals, the dictionary for R in range 0, comma n, C equals S of R, counts equals ord of C minus ord of A plus or equal 1, repeating equals max, repeating counts ord C ord A, while R minus L minus repeating plus 1 is greater than K. C1 equals SL, counts ord C1 ord A minus equal 1, L plus equal 1. Answer equals max. Answer L minus R plus 1, R plus 1. Okay. Oh, whoops. counts key error 0. Hang on, give me 1 second. I'll be right back. Okay, so I made a mistake. I definitely made a mistake. So the counts should not be a dictionary. It should be a list of size 26 populated by zeros. Let me fix all this. Define the counts list. Update the count encountered. Update the count of the characters encountered. Let me make sure this is right. Use a for loop from encountered. Update the count of the character encountered in the list of size 26 in the list. Okay, I think this is it. Just check what's going on here. Okay, I made a mistake right here. We don't need to increase r plus 1. I'm not sure what's going on here. Okay, I made a mistake right here. All right, I need to document this. Okay, so this is wrong. Okay. This, as you can see, was a very rocky problem for me. Time complexity is O of n. Space complexity is O of 1. You know, you can't get good at LeetCode unless you're doing things, unless you go through some of these rocky problems, but there were a lot of tricks to this problem. I found it rather complex as a problem, but I'm glad I did it. So thank you very much, everyone. I'll see you at the next one.